Welcome to today's solar and chill session. So, a bit different than the usual stream, so we're not working directly on printers, but I have a couple of boards that I want to fix, or at least attempt to fix. I've never tried something like that before, so let's see how it goes. So one board is the front section of the toolhead board of this SP2209 we have in here. So last week basically we installed that and figured out that like the LEDs don't work, and we did a bit of trial and error and found out that it must be the front section of the board that has a fault, and we did like some more searching and we figured out that there is one chip or like one component, electrical component, that causes the issue most likely. And I ordered a couple of them. So yeah, it was like I think 70 cents on AliExpress. So basically we will attempt to remove this one from the board and replace it with a fresh one. So that would be board one. If this is a success, I'm already super happy. Then board two. This is the main board we had in Switchfire before. And what happened here, basically, I moved the tool head and the printer was connected. Or like the motors were connected. I moved the tool head like absolute noob, and yeah, turns out physics applies. So basically, when you move the tool head, right, you move the motors. The motors induce current, and if you move them too much or too fast, you blow the stepper. So this board has two blown steppers. I actually did like some testing here, and I managed to remove them. So that's a success. This was my first attempt on removing a stepper, and as you can see, it's yeah, it went semi well. So I damaged a couple of traces here. So this will be really hard to replace. Let's see if we are successful. So we need to patch some traces. The second one, lesson learned, went quite well. So basically the difference is I learned I have to preheat the board. Because otherwise, I think the problem is that there's this like massive heat sink underneath that's really designed to like pull heat. And if you're trying to solder on top, it's really, really hard to solder on this board. Because I think like all the heat goes into this like massive copper layer most likely in the middle. Yeah, it makes it really hard to solder. So what I learned to do is I preheat the print beds to 110 degrees, put the board on for a couple of minutes, let the entire board soak up the heat, and then it's kind of okay to solder. So that's patient two. So obviously we have to replace the two TMC stepper drivers. I think we will try the good one first. If that works, we attempt this one, because this one is really, I'm not quite sure if we managed. But even if we are like losing one driver, I think the board is functional, because you still have 3 for XYZ, and if you combine it with the toolhead board, you don't need the fourth one anyways. So that will be fine. And then this one actually also has issues with both fan headers. So there's a little transistor here, just above the fan header here, and there's another one up here, and both of those are also blown. That's like your old problem of mine. I basically tried to like change the voltage from 24 to 12 volts, kind of screwed up a bit, and broke both in the process. But yeah, so this basically the transistor here is broken. So basically that causes both of those headers to be on the entire time. You cannot control them anymore. So I also got a couple of those, and we will try to replace them here as well. So that's basically the patient number 2. And then we have patient number 3. Let's see how far we get. That's the second board that used to be in this printer. And yeah, I moved the print head and I also blew steppers here. So exact same problem as the other board. It's just like different steppers. So here we have the Z and extruder. So those two steppers, the ones with the plugs are defective. Let's see how far we get. But even if we just unsolder steppers, I think that's like a improvement, because then the board is technically usable again, just with less steppers. Okay, so that's kind of like the introduction, what we're going to do today. So let's start by just taking this quickly apart and getting our patient. I'm really curious how it goes. So I watched like videos on how to do like this hot air soldering. I ordered like a hot air gun because I think that's much easier. It looks much easier than with the soldering iron on the board with the S&D components. So yeah, I'll got a semi-cheap one of those. And hopefully it goes smooth. I did a couple of test runs. So I completely desoldered and resoldered the buck converter. And it still worked afterwards. So I'm semi-optimistic that we managed to do that. Okay. Now we have space. Okay. So basically what we're going to, or attempting to replace, let's see how it goes, is this little chip here. The challenge will be a bit that we have this header here, which we cannot damage. Challenge here is basically it will melt. Like if we use the hot air gun here, these are kind of fine, I think, like from my experience with the other board, they are relatively like resistant to heat, but this connector will absolutely melt. So potentially we need to desolder this one first, just make a bit of space. Let's first get this out. Oh no, also ordered a new fan. Didn't arrive yet, but so the printer's printing's somewhat okay. Like still a lot left to be desired, but I'm not quite sure what the problem is. One problem I definitely identified is cooling. So I had a different fan in here. If people watched the previous streams, remember, so basically the fan was like hitting the Nomi on the front. And after a bit trial and error, basically we found out just like the fan is just not spinning freely. So I ordered like a very cheap one just to replace it. And yeah, it's cheap. It's silent, or like it's quite quiet, which is great, but it's just like there's not a lot of airflow. So the cooling performance is abysmal, to say the least. Okay. So the good one is if we break this board, I don't have a printer for a week, but a replacement board is like €8. Potentially should have ordered that already. So I think we really have to desolder this block here. It's just a little bit too close. But that should go quite easy, I think. Let's see. And I also was kind of like an upstream build. I built an air filter for soldering. So figured it would be like a good investment if we solder a lot today. And I wanted to have one for a long time and never managed. Okay, let me see that I get this all in a way that I can work, you can see. And the fun part is I will also need to look at the camera image because the camera image is much larger than what I see actually in real life. So I kind of rely on that too. So yeah, I think let's start. So this is the hot air gun I'm gonna use. From my testing, basically what you want is like around 400 degrees, and I always had it like on 40% ish. And I'm just trying to not melt anything random on my table. That would be quite good. Quite good start. Hi, Jim. I think what happened is that I pushed on the front of the stealth burner, and I think I offset the pins like one vertically, and something shorted out or broke. But we basically through trial and error figured out that this board is faulty. Like the main board is okay, because if we directly plug wires into this header on the toolhead side, the LEDs work. So it's really just that this little like logic level shifter here, this one must be broken. So that's what we need to replace now. Yeah. So let's see if we get the connector off, then we have a bit more space to work, because I don't have a second one of those connectors. So I cannot melt that. Let's see if I can. Let's see if it works. It's the biggest part I ever desoldered for sure. With a bit more power. Isn't doing much. Oh, it is doing something. Ha! Just as I said, it isn't doing much. Perfect. And I think we already kind of like... Yeah, we kind of already damaged the connector a bit on the side, so it's good we unsoldered that one. Let's see. Okay. I'm not really like down with technique for that. Like it's really like more or less the first time I'm doing that. So learning. Okay, so this is the bad boy we need to remove. This one here. I hope that goes a bit quicker than the other one. Or the connector. Okay. I think that went quite well. So I'm just not quite sure if we now, hi Steve, if we now should clean up the pads, or if I should just like reuse the solder that's on there, because potentially I'm incapable of like putting the solder back on properly. So that's the new one. I think let's just try to use the solder that's already on there. Let's see. quite tricky to grab the part properly, I think. So kind of have to grab it quite high up. I think like this is okay. Yep. That did not work. Let me quickly rearrange stuff a bit here. That's a bit closer to me. It's really hard to like have the piece, the part properly like in the tweezers. I think it's on. I think it's on. Like all the pads are where the pads are supposed to be, I think. Kind of looks good. Problem is like we can't really test it until we put the connector back on. So I don't know. I think that's it. And you're following, I just put the board vertical. So my idea would be that I can hold it from one side and melt the solder from the other. So I think it's best if I try to push it in a little bit on one side and then like wiggle it in. You know what? Let's actually clean this up first. Let's remove the solder that's under. Then I think we will have an easier time installing this back in. Yeah, like this part, like it doesn't really like melt easily. Oh, it is molten, I just don't see it. Top part at least. Okay. Now they're all free. Let's see. Okay, some. Oh yeah, there's one where like a little bit of solder is left. Let me quickly clean this out, then we can like just put it in. Yeah, now it's free. Still doesn't quite want to go in, so let's just heat it a bit, but I guess. Here we go. Good thing is now it's a little bit secured already. And we just have to like, I guess it's easiest to just use the soldering iron and solder those back in. Cool. I'm curious if this fixes it. Fix it. It's really just like this one part. Let's give just like another 5 seconds to heat up. Just doing the edges first, the corners first. Now it's like hold in place. The fan actually works quite well. Like, not sure if you see it on camera, but no, not really. It pulls the smoke quite well. Okay, let me just touch up each. That more. I think I used a bit too much. That's... The bottom one doesn't really want to. Doesn't really want to look nice. Okay. Perfect. That is patient number 1. I think like the like replaced ship looks pretty good. Now the question is was that a problem? And did it fix it? Let me quickly clean up the board a bit because it's like super sticky. So I use this flux to like make the solder flow easier, but it always makes the board like super sticky. And technically, like, I think kitchen towel is maybe not the best choice for this to clean, but it is what I have. Perfect. Let's put it in and see if that helps. Let me make a bit of space. I just realized I made one mistake. I don't have a power cord for the printer. Need to quickly grab one. Oh. Let's see. I don't think I remember all the cable, but I think it must be like this. Oh, what happened here? It split up. Yeah, I think that's how it was. It's the only order they kind of fit. Cool. Let's carefully put it on. We don't do the same mistake again. Now it still fits on. Let me just quickly secure it with one screw. Now we can see if everything works. Okay. Yeah. Let me quickly grab a power cord that we can turn on the poor thing. I'm back in 30 seconds. Perfect. I already plugged it in, so I guess moment of truth. It didn't explode and the Nomi turns on. Now the question is, after the printer booted, this should turn green. If we get a green Warren logo here, we have a successful fix. Let's see. So if the Nomi connects, no LD, we were not successful. It also says printer unoperational. Yeah, now it's connected, but there's no LD. So we did not fix it. Also, like just setting the color here. If you check the fans work. Fan works. So we didn't break it more. But then the question is, what else can it be? Because like we last time, like we directly plugged in the LEDs to the board here, to the top board, or like the side board, however you want to call and the LEDs worked. So it must be the front board. But there's only one electronic part in that entire like thing in the front, and that's the one we now replaced. So I wonder what else it could be. Let's really take it apart again. Bit sad. I hoped that we just like would replace the one component and everything would be magically fixed. Yeah, let me take this down again. Otherwise, I don't have a lot of space to work here. Okay, so this is the part we replaced. And last time we also checked the resistors, but they're fine. So then I'm not quite sure what it could be. I don't quite remember if I think we also tested these LEDs, right? Let me quickly grab, just like to ensure that like when that broke, we didn't break the LEDs or something. I think we soldered like the matching plug on the LED strip I have laying around. Let me quickly grab that, and we plug in the LEDs here and put it back together just to see if the first LED also broke. Because then basically if the first LED breaks, like all of them won't do anything. Let me quickly grab that and let's try again. Okay, so yeah, last time we made this. So let's just plug this in, put it back together, and then see if these turn on. Then we know like the LEDs are somewhat broken. Let's see. I mean, if one thing breaks, it's relatively likely another thing also breaks. Okay. Again, like basically when this turns back to the Boron logo, we should have some LEDs here. Nope, no LEDs. No LEDs, okay. I wonder whether we should like quickly like backtrace our steps a bit and see if we like plug the LEDs directly into the mainboard again, if we then get lights. Let's quickly do that, and if that doesn't bring any insights, then I would just order a new board, because like the front board's like only like 7-8 euros, so it's not like a horrific loss. And that was like worth the attempt of fixing it, but okay. Yeah, then I need jumper wires. Right back in a second. Maybe at some stream in the future, like everything I need is here, and I'm super well prepared. Let's see, let's use those three here. We quickly have to look at the schematics again. Did you have them out in the config cause they were working? No. Like I can control them also. Like still they are here. Like I can control them. If they wouldn't be in the config, they wouldn't be here. So that should all be fine. So we need the SP2209. Yeah, this is what we used last time. So we need the top one out on the outside for ground. Let's say black is ground, that makes sense. And then we need 2 free, and then we need 5 volt. And then we need the LEDs. And then we need to quickly check the config, which we can't open now because the printer is off. Here's the config. Let's quickly check. So the hot end RGB is GPIO 16. Oh, it was right here. GPIO 16, which is 1, 2, 2 free, and then yes, okay. Then we need to connect it here. So black is ground. White is 5 volt and brown is data. Let's give it a shot. And basically, if they would turn on, it would be like completely random colors because these are like different LEDs than the one in the configuration. So if we get any light, we are golden. Let me also open the web interface in parallel. Yeah, there it is. It's green. Not sure if you can really see it on camera. Yeah, it's green. So this works. So still, it is something on the toolhead board, like on this like daughter board. Then I'm just not sure what it is, to be honest. Let's check the schematics again for that. Okay, so yeah, this is just this block here. So this is the part we replaced. And there's just like 1, 2 resistors and this capacitor. The question is like, I'm not quite sure if we can measure the capacitor because maybe the capacitor is broken. I'm not quite sure. Actually, I have no clue about that stuff. There it says. Yeah, I think we can measure that. Let's give that a shot. Would be hilarious if I ordered the wrong part. Okay, so let's quickly do the resistors again. So we have the 2 resistors here. And that's 100 ohm. I mean, the resistor also can't really break, right? That's 10 kilo ohm. That's the other one. That's also correct. And then here's this little capacitor, I think. So that should be 0.1 microfarads. And that reads as 220 nanofarads. I'm not quite sure. I think that's 0.2. Let's quickly Google that. So 0.1 UF in NF. So we have 0.1. I'm not quite sure I need to table for that. Yeah, it should be like 100 nanofarads. So this is like a little bit more than double. I'm not quite sure if this is like within tolerance or if this means it's broken. There's another one up here, which I think is part of the fan circuit. Let's see if we find another capacitor on the schematics. I think that's the only one. There's no capacitor here. Here's one, 4-wire fan, 0.1. Yeah, I think that's the one that I saw on the board here, because it kind of like fits with the 4-wire fan. So let's just give this a shot. So this is like up here. Let's just see what we get if we measure this one. It's the same. That's like also like 230 nanofarad. So I think the capacitor is also fine. But then like what can it be, right? So basically we have 2 resistors, we have a capacitor, and we have the logic level shifter. The logic level shifter we replaced just now. I mean, maybe we replaced it incorrectly. So we can just maybe try to like take it off again and put it on again. Wait, kind of looks okay. Put your jump leads back on the daughter board and check for 5 volts. Then you will know if it's voltage or signal fault. Well, the thing is like, the voltage is here, right? So if I look at the LED, like that's on from the 5 volt line. And the 5 volt line, there's nothing really here, right? There's like no components really interacting with it except that logic level shifter. I mean, we can quickly put that together and just give it a shot. I mean, it doesn't hurt, right? But I'm fairly certain that the volt, like the 5 volt, is not a problem. Let's just put it in here. It's just so easy to like misplace that. Now I can't quite remember which one. I think the brown one was 5 volt and black one was ground. So we will have 5 volts between one of those. Yeah, I don't know. Like, it's a bit weird. So it kind of works. Like, with the cable it works. So, like, clearly the sideboard is fine. It must be, like, on the front. And we can already measure, right? Voltage will be there immediately. So, between these two, so between these two, I have 5 volt, like -5. This is 5 volts, but this is also 5 volts, which I'm not quite sure if that's correct. So basically the signal is just constant 1. I'm not quite sure what that tells me. Yeah, I don't know. We can quickly try to take it off again, see if I connected it correctly. But I think after that, it must be something really simple, like that's broken, because there's not like a lot of electronics on the board. So we had, yeah, 5 volt between ground and the data line. No, the white one was 5 volt. The white one was 5 volt, and we measured. Let's quickly try again. So the white is 5 volts. White is 5 volts and black is ground. So now we should get 5 volt on this. Oh, that was incorrect. 5 volt on this. Yeah, that's 5 volt. And that is 0. And this is now also 0. But before I measured 5 volts between two of them. Ah, now it's also 5 volts. That's weird. Like, it shouldn't be constant 5 volt for the LEDs, I think. Yeah, let's quickly take it apart again. See if we have like more luck on the second attempt, and then I would just pronounce it failed. Put the printer down again. So then let's quickly take this apart. But it's really like the only thing, like I could have like not soldered this on properly, but it looks good. There's also like 5 volts on the pin, right? So basically this part should convert to 3.3 volt logic to 5 volts, which I also don't quite understand because we just measured 5 volts on the difference. What we could also try, so I'm not like an expert here, right? But just plugging this in straight where the connector is works, right? So I'm not quite sure if we need any of those like components here. Maybe the trick is just like removing, like bypassing those components and just like ignoring the components. I mean, as is, the board will be replaced anyway, so I'm kind of like open to experiment a bit. So looking at this, I mean, ground and 5 volt are already properly connected, right? It's just the data line, the center line. Which should be connected to the center pin here. So maybe if we just remove this component here, like the logic level shifter, and just run a jumper cable from the center pin here to the pin that goes to LEDs, maybe we can fix it that way. Let's try it. And then if that would work, that would then still mean that the logic level shifter is not working, but that's a new part that I just swapped in. So I wouldn't know why this one would not work. Yeah, I think we should start by removing the connector again. Let's see if we can make it a little bit quicker this time. Yeah, it's just weird. I mean, maybe I ordered the wrong component, but it's exactly the same part number, so I would be very surprised if that would be incorrect. Let's actually do it this way this time. That we just remove the solder first, and then we maybe have an easier time putting it out. Okay, add some flux. I don't know, like with the connector in, like it's really not melting this fast. It's really hard for me to tell like when it's melting. Like I think like there's like right when it melts you can see it change. But if you miss this point, like it looks exactly the same. Yeah, I'm really not sure if like removing the solder first helped at all. Here we go. The connector still looks okay, so. Okay, let's see what we do. So let's first take off the logic level shifter, because either way this needs to go. What hot air gun do I have? Like it's this one. I just got it. I can't really tell whether it's good or not. Like it's doing what it's supposed to do, I think. It's working relatively well. Okay, so it's off. So now the question is, do we try the jumper cable or do we try like another one of those? I'm just not quite sure if like, I'm pretty sure it was on okay. So I don't think adding like another one will make a big difference, to be honest. Just quite a bit of overhead because we have to remove the connector and like. So I'm not quite sure if it's worth the time, like trying the exact same thing again. Seems alright so far. Yeah, like it's not amazing quality. Like the nozzles are a bit weird to change. Like, see, it's like super cheap. But besides that, like, I can't complain. I only got it because my soldering iron is the same brand, and I kind of like that one. So I was like, okay, seems like cheap quality, like not cheap, but like good price. Let's run the cable. Let's try something else, because like, what's the point in like trying the same thing over and over again? So I have like really thin 30 gauge wire. So basically, let's just take like a really short snippet. Like first, let's see, so see, it's already too long, and it's really short. Oh, now I ripped the entire isolation off of it. Okay, let's try this again. I think that worked. But it's still like, it's crazy how short this must be. I think I might have to try something like it out, because I really don't have the budget to have a proper one at the moment. Yeah, like they're getting so expensive really quickly. Like if you have like a proper soldering station, like it's crazy how expensive they are. Yeah, but I know they're like dedicated jumper wires where you don't have to remove the isolation, and I definitely see the appeal of that. Yeah, I think this just works. This just works. Question is just if we should use the hot air gun or... Oh no, I lost it. It's gone. Snapped out of the tweezers and now it's gone. Okay, let's try again. Question is just if we should use the hot air gun, or whether we should try to do with the soldering iron. Not quite sure if there's a better way to do that, to be honest. Maybe we can just try to solder it to the tip. I have no clue, because it's really hard to like strip the wire. I mean, maybe if I can just burn it a bit with the soldering iron, like the isolation will burn off. First turn it on. So, I'm really not sure if that will work. Maybe it's smarter instead of running this like wire here, because like one of those will be connected to the center pad. Let's find out which of them, and then let's just run the wire on the back side. It's way easier. Let's do it that way. So the center one here, yeah, it's this one. So we can solder the connector back on, and then on the back side we just run the cable from the back of here to the back of there. It's much easier. Then the cable is like 3 times the length. So let's put it back in place. Okay. So longs, keep it long. So the one setting culture. I'm not quite sure if that works because I also need to go in with the crimping pliers, right? Putting a bit too much on some. Okay, so now basically we need to quickly double check. So it's this pin here. Oh, that's not how it works. So we need to check the free pad in the center. Yeah, so it's the top third needs to go there. Okay. So it's basically the top one here, the third from the top, on the back side, basically. And that's now like a manageable cable length. I'm still like overestimating it by a lot, but oh, now I broke it. Ah, pulled out all the strands. Luckily, we have a lot of cable. Yeah, this is perfect. Okay. So that's the connection we need to make. Okay. Let me quickly touch up the other side. I think that should do the trick. So, I mean, it's really black on camera, but here you see it. So basically now just bridged these two pins, which should mean that now, let's actually quickly check for shorts. Just so that looks all good. And also let's double check we fixed the wrong. Yeah. So now it's bypassed. So I would say let's see what happens. Because like the 5-volt is fine. We know that for sure, right? Oh, let's lean it a bit again. Okay. Let's quickly make some space and put it on the printer. Where did where did I put it at? The tool head. Let's also clean this side a bit. Oh. Moment of truth, basically, almost. It's a question. Let's use those external LEDs first. Because there we know that if we plug those LEDs directly into the board, they work. So now I really don't see why it would not also light up. Okay, here we go. Okay, nothing explodes. That's good. So as always, if we get a Warren logo, we should get an LD. And we have LD. So I'm not quite sure what those like electrical components are supposed to do, but I think they're not really necessary. There's LD. Let's try the proper LDs in the tool head. And quickly shut it down. I always feel bad for like cutting the power. I mean, worst case, the SD card gets corrupted. That's why I have backups. Okay. So I just plug in the LEDs. The rest can stay as is. Let's also only do one screw for now. I learned that lesson often enough. So let's see. Warren logo, LD, and I'm super happy. Here's LD. Let's see if we get all three. Yeah. I mean, you see it here on the sock, but all green. And the white also works. So all fully operational. We have a fix. Like not quite what I intended, but now I wonder why they put useless components on the board. I'm pretty sure there's a reason. I have the suspicion that because they have two versions of the board, right? They have the SB2209 and the SB2209 RP2040, and this is the 2040 version. And one thing I can imagine, because the part that we try to replace, right, is a logic level shifter. So it shifts the logic from 3.3 volts to 5 volts. At least it's what my understanding is of the part. So I think maybe the other board, the SP2209 non-RP2040, has 3.3 volt logic and needs that shifter. And the 2040 maybe has 5 volt logic and doesn't need it. I don't know. That's at least my best attempt on explaining that. Or there's some like other thing I don't understand. Maybe like some LDs need that, some configurations, I don't know. But for me, it's broken. Like something, I mean, I'm still not sure if the logic level shifter is broken because like even with the new one, it didn't work. But I count it as a win. So I fixed the €8 board with the €40 hot air gun. Cool. So that's it. Yeah, besides that, so on this printer, to quickly round the printer off, there's like two more things we want to do, like this kind of like next to them. We have this random buck converter for the fan. I want to get rid of that and replace it with something nicer. That's one thing. And the other thing is once the fan arrived, I ordered at 3DO in Denmark, but they're on vacation until the 15th, so until tomorrow. So by next week it should arrive. And then we can replace the hot end fan, and hopefully then this printer is like back in printing order, printing nice and smoothly. Cool. Yeah, that was the easy part. Let's try to fix the mainboard. Let's fix the mainboard. So let's do a quick sum up first. So I have a Raspberry here that runs Clipper. I have this mainboard. I kind of did a quick check on it already, but let's quickly do that together again. Let me quickly I have, this is a 12-volt power supply, so we can power the board. So one thing you already see right away, like it turns on, it's working. Like also let me quickly boot the Raspberry as well. Then we can just really give it a shot. So it's obviously missing two stepper drivers. That was like my test to desolder on the board. We also make sure. Okay, so that was my attempt to desolder. Lessons have been learned. Like the first one I already showed in the beginning. I ripped some pads, so this one might not be salvageable. Given the experience I just had with the cable bridges, I don't think I am capable of doing those like teeny tiny cable bridges. So let's see how that would go. Even if we don't recover this stepper driver, if we have 3 stepper drivers, I can use the board for some projects. 2 is just like one too little. So this one soldered, like the desoldering process went fine. So we can replace this with one of our fresh TMC 2209 stepper drivers. This will be fun to solder. But it's not the only defect on the board. I think we should start with the stepper, because if that works, like the rest will be like a walk in the park. You also see the 2 green LEDs here. Those 2 LEDs indicate the fan status. So this board has 2 controllable fans, and both of them have this little MOSFET there, and not MOSFET, transistor here, this one. And there's another one here. And those are broken. So we need to replace them. But to do so, I think we need to remove at least those 4 connectors here, because otherwise, like, we will melt the connectors left and right. So basically the things like we need to replace those two transistors and at least one 2209. Let's do quickly just like a status check before we start. And then we can start doing things. Now I should remember how I called that. I think it's mainsail.local. It's not. Let me quickly check on my router. Let me see, do I see that thing? Yeah, it's called mainsail. Here we go. Okay, yeah, the board wasn't plugged in, so let's just try to do it again. Here we go. So that works. I also have, for testing purposes, one of the old extruders here. So just like to verify the other two stepper drivers are working. By the way, never plug in the stepper driver if the stepper driver is driving or is powered. Let's say, put it like that. Not powered at the moment, so it's fine. So what we can do is we can just do like a stepper bus. Actually, I did that already, so that's why I have it here. So this is extruder, and now basically we should just see that this moves. Yeah. See here, there's like wiggles back and forth. So this stepper driver is A-OK. Yeah. Now it's de-energized. So let's move it over. That's the Z stepper. We have a wiggle, so also the stepper driver is okay. So these two are working. The board, you see, like it's in Clipper, it's all fine, like the board itself is working. The only thing that's not working is, of course, the fan header here. So, I mean, I can plug it in, but it's constant on, like there's no way to control the fan here. Okay, so this is kind of like the status quo we start with. Yeah, let's just unplug the USB, and then we can just cut power. There's the status quo. Now the goal would be basically to make that better, of course. I'm not quite sure if I think let's just start with the stepper. Oh yeah, I totally forgot. What we need to do, I think I mentioned it like 5 minutes ago, but we need to preheat this board. So the first stepper, I messed up removing. The problem was I couldn't like melt the solder properly. The second one, what I then did is I have a very professional preheat station. Let me show you my preheat station. It even has a webcam. It's top of the line preheat station. It's a printer. So I just, yeah, you see it here. Like I just put the bed to 110 degrees. And you see here, like in the camera, kind of like the board. So I just put the board on the bed. We let it heat for a second, just like maybe like 2-3 minutes. The goal is basically those main boards. I think they have like an internal heat sink, like a lot of copper inside, basically to like pull the heat from the stepper drivers. And if you solder on that, like it pulls all the heat in there, and you can't heat the solder. So yeah, that's a problem, and preheating solves that. So while it's preheating, We also totally forgot, we need to quickly check the orientation of the stepper driver. So they obviously have orientation. I think step one would also be just to add a bit of solder before we actually put it on, because I removed the solder using wick, so it's totally gone. But yeah, they're like super tiny. Let's see, and these are TMC 2209 LA, and I have no clue what LA stands for. So I hope that's nothing bad and they're compatible. Okay, yeah, step one would be adding a bit of solder. Now we just need to be quick. Let's actually start with flux. My solder cable is stuck. I think it's on. Not quite sure. Those headers are really annoying. Try doing it from this side. Okay, so I think it's on, but now there's like a bit of a solder ball in the middle. So we need to remove this one. But I think on the outside it looks like there's solder on the pads. Like not a lot, but it does need to be locked. Let's put this back on our preheat station. See if we get the center piece removed. But yeah, there was the thing, like you maybe you saw it, but like the moment I touched the center, like the temperature went down and the pin solidified. Be quick about this. Okay, I have to quickly change the. This is not really stable. No, it's better. Okay. But yeah, it's still like I'm not sure how to remove that. Okay, let's put it back on the heater for a bit more. Let's just put the temperature of the iron a bit up, and then also let's add a little bit of flux again on the center. Not going away. Let's try hot air. This is annoying. Yeah, that's what I mentioned. Like, it's really, really hard to solder on this board. Okay, I think now it's mostly off. Should be fine. It's still like a bit. I just feel like if there's like solder in the center, that we are unable to squish the chip down properly. So I really want the center solder free. But lesson learned, next time let's pay attention to not put solder in the center. Yeah, I think now it's fine. Then I would say let's see what orientation. Oh, this is hot. Which orientation we're looking at. I think the logo is just facing upward. Yeah. The logo is just facing this way. So I hope that's the correct orientation for all of them. And this is what we're trying to solder. But now seeing how close this can focus, I'm just not sure if there's enough solder on there, but I guess we will find out. Wonder what's the best orientation to put it. I think maybe like from the side is the most convenient. Let's give it a shot. That did not work. I'm not sure if there's enough solder. Let's preheat the board again. Let's start with that. Doing that. Added Jordy. Yeah, the stepper drivers. And also 2 of the fan words. The fan transistors. But yeah. Stepper driver is operational point number 1. Let's see if we manage that. But I think we have a bit of solder like on the underside now. So the solder definitely melted. I'm just not sure if there's enough solder on the pads. Okay, this is now like a bit awkward because like it takes me seconds to like pick the component up. Just need to be really fast. Add custard. Yes. Flux is my best friend. Let's add some more. The positive thing is it's soldered. It's just not where it should be. So let's do the whole thing in reverse. I think it's on. Like it's not super center, but let's maybe try one more time. Add a bit of flux. Okay, to be honest, I think that's as good as it gets. I mean, it's not super 100% center, but it's like I'll take it center. Cool. Yeah, technically we can just try and see if it works. Let's let the board cool down for a second. Yeah, to try if it works, we also need to solder the header, right? That would also... help a lot. Which means let's not wait for the board to cool, because then we can't solder stuff anymore. And just put the board vertical. I'm not sure if that works. I'm not sure if that works. The connector is somewhat in, but not quite. I hit again and press from the top to make sure it's making good contact. That's a good one. Let me try that. But then let's quickly throw the board back in the printer to like heat it up a bit again. It's the first time I'm doing like soldering like this, so I have no clue what I'm doing. Let's give this like another minute. So what I already noticed, Katsa, like I'm not sure if you were here already, but so the board eats a lot of heat. Like even if you try to solder with a soldering iron, like it like the solder solidifies immediately. So I think there's just like a lot of copper in around the stepper drivers to like absorb the heat. But yeah, it makes it really hard to solder. What we can do quickly, like we can clean up the connectors here. I feel like there's still a bit of use. Pump. Oh, that was not smart. You know what? Let's just replace those. Give me 1 second, I'll just grab different JC headers. They're white, but I don't care if they're white. Okay, so we just placed fresh JC headers, and then yeah, they're white instead of black, but life is tough sometimes. So let's be quick about that. Let's add some extra flux. Problem is now I don't quite know when the solder is liquid. but I think it should be. Just do this for like 10 more seconds. And I think this looks good. Cool, now let's try fresh header. There's still kind of cleaned out the holes, but seemingly not enough. Then let's flip it over. Let's see. This one. Let's just add a bit of solder to the outside one. And we don't lose it. And then we use the fresh solder. I'm just pushing from the bottom with my finger. Just wiggling it in. Let's quickly check. Yeah, a bit more on this side. Okay. And solder the center ones. Here we go. Much easier. And if I now would have folded it on the correct way, we would have success. But now we do it all again. Sometimes I do very stupid things. I mean, why do it in one step if we can have the fun of desoldering in the middle? Struggled with that myself. Basically, your soldering iron can't keep up with the amount of heat needed. Yeah, exactly. I mean, it's also like a very small soldering iron in a certain sense. Like, not small, but like a normal one. Let's actually use the heat gun there. And maybe if you have like a big soldering station, it's less of a problem because like you have much more heat available. Move it so you can see. Yeah, it's a bit annoying because like this step is completely unnecessary. Almost off. Hanging on the last thread. Let's maybe quickly do it this way. I'm not sure where it's hanging. Oh, I'm not quite sure. Like maybe like looking sometimes what you're doing is helpful. There's nothing there yet. This the pull. Okay, let's clean the connectors and the holes. Use the soldering iron for that. Okay. New connector, new luck. Facing inward this time. Luckily, this direction is much easier. That's what I said. Before messing it up. First time I desoldered those headers, it was not that much of a pain. Okay, let's try the hot air again. I'm not quite sure why I'm incapable of soldering this further. For some reason, this is not going in. Let me quickly back it out again. Really stuck. Okay, success. So 1 second break. Then let's clean out the holes properly again. And then solder the header from scratch. Okay. I'm really curious to see if it works, but the header is like quite a pain. Okay, let's clean out the hole. Okay, at least that went well. So, no, this header is not good anymore. There's like one pin that's not where it's supposed to be. Okay, let's do the fresh one. Like I'm not in the mood of doing this again because the header is broken. See, now it's like just falling in place. So next time, let's just do it properly and clean out all the holes if it doesn't fit in right away. Direction is correct. Okay, then I think now we could technically test everything. Maybe let's let the board cool down for like a minute. And while the board is cooling down, we can clean up a little bit of the flux. Yeah, like with this struggle, I see no way how we like replace the TMC with the broken pads. Like, I don't think I'm capable of doing that. So maybe we should like accept it as a win if this one works. And then this board is just like, I mean, it's usable if you have a tool head board, a separate one. And I actually have something planned where we could use this. So yeah, that's why I started with this board. And like I still have this one to fix, right? It has the same issue with like two steppers broken, but this one is much nicer board than the older one. So I tried the old one first. Let's see. I don't quite trust the... Yeah, there's a bit of metal poking through, so let's not have it in there. Okay, so step one. Let's give it power. And it didn't explode so far, so that's good. So that's that, and then we need a stepper. I'm trying to position everything so you kind of like see the board and the stepper, and I'm not gonna hide the magic smoke from you. So now we're at stepper Y. So let's just do our stepper bus. Moment of truth, right? So if it works, works. If not, I have no clue how to fix it. All or nothing. 3, 2, 1. Clipper shutdown. Unable to read TMC, UART stepper Y, register IFC and T. I would say that's a no. It doesn't work. So I mean, it could mean it's just not properly on. Yeah, I don't think there's enough solder on the pads. Like if you look from here, you look really close. Like I don't think the pins make contact. So let's try this again. I'm not going to remove the plug, which most likely means the plug will melt, but now we just pull out the single pins, which is easier. Let's preheat the board. I've seen some videos on fixing broken pads, and it's definitely very hard. Yeah, I think so too. So I don't think it's like, if I get this one working, I'm already like really happy. Like, yeah, if this one stepper is working, I call it a big success. Oh, we could have turned on the heat gun first. So I would, let's remove the stepper altogether again, and add more tin to the pads. I think there's like almost no tin on it, so maybe it's just not enough. Okay. Let's use some wick and clean up. If I find my... right in front of me. I think maybe it's also the solder block in the middle. There's still too much solder here. But yeah, I don't get it to flow. Let's heat this up again and then be very quick. Nope, doesn't work. Horrible to solder on those things. I know I will regret it, but that's it. Success. No, I soldered. Oh, this is so annoying. Yeah, but I just don't get the solder off there. Like the soldering iron just doesn't have enough power. No, it's a bit, but there's still like mountain of solder in the center. No, no, it's again stuck. Okay. Oh yeah, and the connector is like already burning and melting. That's what I meant, like it's most likely not surviving. Let's try just to add a little bit more solder tin on the pads. And I also want to add more solder in the center. So I made the problem worse. I think there's enough solder on the pads because like the pads just take like the amount they need in a certain sense under the flux. Now the question, what do we do with this massive solder lamp in the center? Okay. Let's preheat the board again just to make sure it's like kind of heat soaked, but it's like technically quite hot. But I don't have a bigger tip at the moment. I lost my big tip. I was looking for it like this afternoon and I couldn't find it for some reason. I have no clue where it went. Like it always was in this box. But it's not anymore. Oh. No clue where that went. That's my problem. Like I have this like nice big tip. And then yes, it just has like more thermal mass. There's no clue where it went. I should order a new one, I guess. Because it comes in handy. Okay, let's try it quickly. Yeah, like I kind of get it on its own, but as soon as I add the wick, okay, so soldering iron is no go. Let's try with the hot air. I can add up the temperature here a bit, but I just feel like I'm burning the entire board at this point. I think we're getting a bit off. I think it's gone. Now the question is most likely also the let's be very careful and try to add solder on the pads without adding solder on the center. And then this needs to be this needs to go away again. Okay. One more attempt. I mean, I knew that this would be like very difficult. So no, I touched it in the middle. Yeah, back to start. I touched it in the middle. Okay, well, at least we now know how to get it off, but I just feel like if I do this, I also pull the solder from the pads around. Okay. Let's try one more time to add bit solder on the pads. And then we just try It's so hard because like all the components around, like you cannot draw in a straight line because of all the components, and I touch the center and then we start over. I don't know if I'm incapable or it's really hard. Am I using lead-free solder? I am not sure, to be honest. I don't know. Like it doesn't really specifically say lead-free. And yeah, the connector is gone. That's why I desoldered the other ones. Let's add a bit more flux. Okay, I think it's clean again. Let's try one more time. It's always this one. Okay. I'm really losing my patience. Man, this is annoying. Okay. One last attempt. If it's not working, it's not working. I just don't know how to access that because like there are like the two caps left and right. It makes it really hard to just get to that with storyline. Yeah, I think I have it. I also think there's one pad that's now broken. Oh no, there it is. It's easier if I go away from. If I pull it this direction, it's fine. Okay, it looks good. Okay. Well, I'm not quite sure if I should reuse this one because it also has a bit of solder on the bottom. Let's, I set this aside. Let's use a fresh one. I want to have the best chance of success. Let's try it. Off we go. Nope. Well, almost. Add a bit more flux and then try to press it down. That's so hard to know. Like when the solder is liquid to press it. I think now it was. Let's do a visual inspection. And what we could also try is to just use the solder iron to go along to just make sure that there's like a little bit of a connection. Because I think like last time the problem was just like that we couldn't that there was like not proper like proper solder connection. Let's just try this. Okay. Now it should be fine. Hopefully. We just have to fix. To be honest, let's for testing, let's leave the connector as is. You don't have to like solder the connector now. If the label says something like SN60PB40, nope, SN99CU1, then it's lead solder. That's what you want because lead-free solder has a higher melting point. PCB manufacturers use lead-free solder mostly. Okay, so lesson learned. I have the wrong solder then, which so far was never a problem, but I guess with these annoying solder drops, I guess it makes a big difference in the end. I put so much flux now on that. Hey, like, I mean, visually to me it looks good, but yeah, I think this time there's more solder on the edges. Okay. Let's give it a shot. So far, so good. Let's not even plug in the stepper. So basically, if we get a stepper bus and it doesn't completely freak out, then I think we already have success. Here we go. Yeah. But it's different. It's different. Under voltage. That is different. Before, like, we couldn't communicate with the stepper, so that is now different. Just trying to see if there's like anything obvious. I mean, that's the one we soldered here. I mean, potentially it's also just more broken than just a stepper driver. I don't know, like the connections all look fine to me, as far as I can tell. I mean, we can just try to touch up the solder connections around again. But I guess that's then a no. I mean, the other one, it has a bit more tin on the connectors, I think. Let's just try. But I have very low hopes. Yeah, this connector is it's done for. Let's just heat this up and then we can also try to just like to resettle the chip a bit. Maybe just take it off, put it on again, see if that helps. Well, it won't work like this. Okay. I'm trying to get it perfectly centered, but okay. It's on. Let's do the retouch again around. Cool. Let's clean it up again. And then if it now doesn't work, I would just call it quits, and then maybe we can try at least fixing one of the fans. But at least like it's getting easier to solder and desolder the chip, I think. Not sure if that's because I'm getting better or because the solder job before was so bad that it's like just falling off. Okay. Let's see what it's doing. Hi there. Hi there, Akar. I usually remove those connectors. Yeah, like the thing is like I removed them, I soldered it back on, it didn't work. I added it back and now I was too lazy to remove it again. Yeah. I don't know, like I kind of gave up on that, so let's see. Because they keep melting, yeah. They keep melting. I use cotton. Yeah, I don't have anything like I know you like the Q-tip swaps. I think they're way better, but for some reason I didn't have anymore. So kitchen towel it is. Okay, so the board is, I mean, still running. Let's just see. So we had before our GS stat under voltage. Yeah, still not. Yeah, now we are back to the first one. So the second solder was better than this one. At least like it could communicate. Okay, then I would call this quits for now. Let's see if we can at least like fix one of the fans. And there we definitely have to remove the headers. It's a shame. Like I hope this would work. I mean, I'm quite proud that I got it on at least. It's just like if it doesn't work, it's not good. But I mean, the chip is on the board. Like it's very plain. Like there's no like gaps or something. So, otherwise, you have been. Rogue solder ball. SMD connector below the chip. Oh, I do have. Well, that's under. Oh no, now I have it here. Thank you. I don't think this did anything, but wasn't there earlier? So yeah, most likely when I used the solder pump, something fall off or something. Yeah, it's a shame. Okay, let's try to change the transistor here. So let's desolder those four. Can I get this right? Yeah, it's like these two. We need to desolder. Let's see if we have more luck with that. Maybe not proceeded. Worth removing and checking. You think this mode might have caused the error? I mean, I didn't do anything yet, so we can quickly check. But I don't think this would have done much. There's no need to remove the entire connector, just remove the plastic part. It can be plugged back in after it cooled. How do I remove all the plastic parts? That was always quite stuck for me. Yeah, it's still the same. Yeah, it's still the same register, so that didn't do anything. I'm not sure if it's schematics. No, like, it's still doing the exact same thing, so. I mean, let's see if we can remove the plastic part only. Oh yeah, that works. Not sure why I never considered that. Thank you for this tip. But I think the molten one is baked on. No, it's also coming up. Okay. Let's see what we can do with a lot of fresh power. So let's add some flux and pop that off. Actually turn this around. Off it is. I think I'll save myself the hassle to like remove the solder. I think we can reuse that. It should be fine. Let me see. That's the other part. Here. Here we go. You can use thermal tape around it. I don't like the smell of plastic. I don't think anyone likes the smell of plastic. And it's gone. Ah, here it is. Okay, let's see if we can get this back on. That was easier than the stepper. Let's see if we... So technically, we had 2 green LEDs here. If we now have 1 green LED, I think it's fixed. It's not as bright, so I think it's doing something. Let's quickly swap the other one. Okay, so both are swapped. Now both LEDs are off. I'm not sure if this is good or bad. We'll find out. Okay, so technically one of them is the hot end fan, or like the part cooling fan. So if I turn on the part cooling fan and we get an LD, it's fixed. But the Clipper doesn't come online anymore, so I think I just broke the board right now. Let's see. Nope. Ah, here it is. Okay, ooh, Clipper has the board. It's working. Fan off, LED off. Fan on, LED on. Amazing. So this fan is fixed. I'm just not sure what the other fan is. Let's quickly check the config. Let's check the config. So we have one fan, PC6 and PC7. Let's just swap the two. So now the other LED should turn on. The other LED turns on. Success. So the fans are fixed. We don't have steppers, but the fans are working. So it's something. Yeah, it's something. Then let's put the connectors back. Let's actually quickly clean before we put the connectors back. Then I'm not sure if I have the energy of trying the stepper again. This actually makes me very happy because I was like, I broke this board, or like the fans on the board, I think like 3 years ago or something, most likely a bit more. And I was so annoyed. And I tried, like I had for a while the fans and controlled by Octoprint from the Pi, but didn't really work. It was a kind of like a pain. And then I bought like another board. But yeah, I was so annoyed. And now like having this fixed is kind of like a nice thing. Applause. Thank you, Ender. So I guess it's kind of like semi-positive success, I guess. Wait, the pin is a bit crooked. Because I mean, we fixed the toolhead RGBs, RGB LEDs on the switch wire, right? So that's success. We didn't quite fix it in the way that I hoped we would fix it, but I mean, it's working, so working is working. We fixed the fans on this board. It's just like if we get one stepper fixed here, you know, like the problem is kind of solved, because then like you can use this with the canvas toolhead board and it's like amazing. Then it has really utility. It's just like if you only have 2 steppers, it's like you can't really use it for much, which is a bit annoying. Let's try this again. Let's try to remove the stepper again. I'm just not sure what to do different, to be honest, because like we had it now, we tried 3 times, right? The first time we got the register error. The second time we got under voltage, and the third time we got a register error again. So, I mean, it makes a difference. So maybe it's just like not 100% on. Well, solder's all molten. Let's just get rid of, or at least try to get rid of the solder in the middle. Okay, let's see. I mean, it looks not like I broke the... Like there's some pads on the bottom that look a bit like they don't have a lot of solder on it. But it's maybe something we can fix. I think my solder tip is a bit ruined. Doesn't take solder. Let me quickly switch the solder tip. Maybe no? No. Like the problem is like the solder doesn't stick to the tip for some reason. Like it's somewhere on the side. Not sure what. Maybe it was on for too long and kind of burnt. Okay. That means we need to quickly switch the tip. How do you plan on glue the coolers? I did not think yet on the coolers. Or like, you mean the small heat sinks, right? Like I have no clue yet. Like usually I just have like double-sided tape that's relatively thin and that works quite well. I also use it with Raspberry Pi heat sinks and it works well. So that was my plan, but nothing specific yet. Can you use cleaning water? You mean the wick? Yeah, the problem is that in a second, so basically I can solder the wick to the board, but my soldering iron doesn't deliver enough power to really like melt a lot of solder. The problem is that I think that's like my explanation. Below the TMC stepper drivers, there's this massive copper area, and I think it just takes so much heat, like it just pulls all the heat from the soldering iron. So it's really hard to solder on this board. Clean the tip with a wet sponge. Okay, I'll do so, Kessa. Thank you for a tip. Thermal pads, yeah, I would also use, I think, but I think they don't really stick right. At least the ones I have or used in the past. They didn't quite stick. But also the heatsink, right? That's just double-sided tape on the bottom. There's nothing fancy about that. Like, it's just double-sided tape. Okay, let's see if we have more luck with this tip. Things I'm just not sure if, like, you know, something else than the stepper driver broke. Nope, that's too much. So maybe it's just like what I'm doing here is kind of like fertile, because like the problem I'm trying to fix is not really the stepper driver. Oh, sorry, I'm out of fuel. Okay, so on this side, I definitely have too much solder now. Okay. Yeah, that's what I mean, Ender. Like, it's just like I'm not putting enough heat in it, and I lost my big solder tip somewhere, which is not helpful. Okay. Let's try again to just place it. Okay, so I mean, this time I really know, like, it was like floating when I pressed it down. So that's something. It's a bit crooked. It's a bit crooked. I think paper leaf pieces, yeah, they do. I recommend that you warm it up by moving it gently rather than keep it fixed. You need to warm up like the general area a bit. What's the benefit of that? I have no clue. Okay, so this is the last attempt, and then I would accept that we tried our best. So basically like that is like more even, basically. At the moment I heat one side more than the other. That's what you're saying, right? Okay, so let's see. Yeah. What do we get? Register, under voltage. Register. So it's 3 times register and 1 time under voltage. So yeah. Not quite sure what to do with that. Because I don't think I mean, now it's a little bit crooked, but it's still in line, I think. And it's not the 4th time we placed it, so. But I remember that like the one before also gave like errors like that. Like communication errors, basically. So I'm not sure if it's really the stepper or if there's something around that also broke that causes that problem. So yeah. Yeah, I'm not quite sure what to do. We could try to replace the stepper on this board because I have a second board where I have the same problem. Let's do this last operation for today. Let's try to do the other board. But then we should now let's leave it for next time. Or for another time. I'm not sure if it's next time. So basically, I have this board where also 2 steppers are out. The problem is I pulled the steppers off here before I did like an extra check. So I'm not exactly sure if the previous stepper had the same error behavior as this one now. So for this one, let's do a little bit more structured. So let's test the board next time before we take it apart, basically. And just make notes of what the steppers are doing, like how the board behaves when we try to access those steppers. And then basically pull off one stepper, try to replace it, see what happens. I think this is like, for me, this was the learning board where like I just wanted to try it out because this is kind of like a nicer board. I mean, it's kind of broken already, but you know, you can always make it worse. But yeah, I mean, it's a success in the sense we fixed the fans on this board, which also means I have one more board with a broken fan header that's currently in the switch wire. So maybe we can fix that fan header. That would be nice. Because that was like quite easy to do. And then basically for the steppers, I mean, I have 4 more fresh steppers, so we can also try like another one. But yeah, worst case, I spent 15 euros like on like SMD components. They're like €2 per piece, and I ordered like 6. So the loss would be not too bad if it doesn't work. On the upside, more soldering. You mean on the board here that I just did? Yeah, it's a bit uneven. It's like it's a little bit like twisted on the board. I'm not quite sure if that's the problem. Here's the close-up. there's, it's just like the chip is like not straight, right? It's just like a little bit twisted in this direction, basically. And so I didn't place it very well. It's like a little bit more down and a little bit twisted. But it's the same register error we got before when it was like better positioned. So yeah, I'm not quite sure. I'll just try again, maybe tomorrow morning, just like with a fresh head, try to place it again. But yeah, I mean, we can try it again, right? Like, it's not like we're making it worse by taking it off and on. The part should fit. I mean, there's one thing that I kind of like wondered, and I didn't check yet. So let's maybe quickly check that. So let me quickly check. Because what I ordered, noticed that a little bit too late, was a TMC 2209 LA. Now, I'm not quite sure what the LA means. So I'm not quite sure if there's a difference between the two. Yeah, that's the one I ordered. It's like TMC-LA. Now I'm quite sure what the LA means. But I assume it should be what I need. It's a very bad search term. Yeah, no, there's no difference, right? There's the TMC 2209 LA, which is the one I have. Then there's the T, which just is the tape reel packaging, which technically is what I have, I think. And then this evaluation, like that's just the connector and baseboard. So I think it's the right part. I think. But now, like, I wonder, is it 2209 or 2208? And does it make a difference? Deep breath and again. Yeah, I think that's what it will be, but not today anymore. That's a schematic. Let's quickly see. No, it's TMC 2209. It's 20. So I have the right part. It's definitely the right part. Yeah, let's see. Yeah, I'll try tomorrow, and then we can do like the other board in another stream. Yeah, thanks everyone for tuning in. Was a bit different than usual, but I think it was fun. We had some progress, I think, or like some successes, some setbacks, but yeah, was fun. So thanks for tuning in and enjoy your weekend. See you next time. Bye.